The low-power Flexis series of QE family microcontrol units. Welcome to this module on Flexis QE family microcontrol units from Freescale. This module will cover ultra-low power with the QE128 and discuss power management features and clock management features. This TechCast is 17 pages in length and lasts just over 20 minutes. The Freescale controller continuum offers stepwise compatibility across the portfolio of consumer and industrial microcontrollers, MCUs, with a common set of peripherals, tools, and software to provide an optimal combination of performance, economy, and functionality. The Flexis series of controllers is the connection point of the Freescale controller continuum, where 8 and 32-bit compatibility becomes reality, delivering the ultimate in migration flexibility. The 8 and 32-bit QE devices are the first Flexis series MCUs in this new series of the continuum. The term Flexis means a single development tool to ease migration between 8-bit SO8 and 32-bit CFV1, a common peripheral set to preserve software investment between 8-bit and 32-bit, and pin compatibility wherever practical to maximize hardware reuse when moving between 8-bit and 32-bit. The above lists the measurements for reduction of the power consumption of these MCUs. With these features, the Flexis series MCUs can maximize the performance while minimizing the power consumption. By giving careful consideration to the clock source, clock distribution, and clock mode on a module basis, and using the correct CPU mode at the right time and for the right length of time, the tight power consumption limits placed on modern consumer and industrial products can be achieved. The QE128 family is an industry leader in ultra-low power technology. Both devices offer ultra-low power on the market to date. It boasts many energy-efficient features. New optimized peripherals enable better power efficiency to help extend battery life. The QE128 offers low run currents in a low-power run mode. A combination of low power and high performance offers unique flexibility to turn peripheral clocks on and off to use only the current that the application needs. The QE128 has multiple power-saving modes, such as stop modes, a wait mode, low power run, and low power wait modes. Other features that enable low power are the clock gating techniques, an internal clock source, the new ultra-low power 32 kHz oscillator with a standby current around microamp, a new voltage regulator with a fast wake-up time, and a real-time counter. Choosing the right CPU mode for the right stage of the system design can make or break the product's power consumption targets. Along with the usual run mode, the QE128 has 5 other power-saving modes: wait mode, low power run and low power wait mode, stop 3 and stop 2 mode. Stop 2 is the lowest power mode with the lowest functionality and the slowest wake-up at around 29 microseconds. Stop 3 mode is also very low power, but it does have more wake-up sources and a faster wake-up time of around 6 microseconds. In general terms, the faster components are clocked the more power they consume. In applications running over 95% of the time, the MCU solution provides the lowest overall power consumption, is the one running as slow as possible in that system. In many cases, the application performs at the lowest overall power by performing the scheduled tasks as quickly as possible to allow the MCU to go back to a very low power state as soon as possible. The heart of the Flexis QE series is the internal clock source module, or ICS. Designers can use the ICS module to select an external reference clock, ERCLK, from 32 kHz up to 16 MHz, or an internal reference clock, IRCLK, that is in the range of 25 to 41.66 kHz. The heart of the ICS is the frequency lock loop FLL block, which multiplies its input clock up to a specification maximum of 50 MHz depending upon the module's configuration. Compared to a PLL, the FLL enables faster stabilization. This allows the application code to start sooner, so that changing the FLL frequency is not as large a penalty. The FLL can also be bypassed if a low-frequency bus is required. A divider block, bus frequency divider, BDIV, can divide the clock signal down by 1, 2, 4, or 8 before it is put out onto the ICS OUT signal. The MCU bus clock is ICS OUT divided by 2. The real timer counter is a basic timer used to generate a periodic interrupt. It is the only timer function available in the stop modes. It can generate a periodic wake-up from stop 2 or from stop 3. There are 3 clock sources for the RTC, including 1 kHz low-power oscillator, LOP, the output of the external crystal oscillator, and the internal reference clock of the ICS. By gating off the clock to unused modules, precious microamps can be saved in the MCU's run and wait modes. This feature is especially important because of the numerous communications modules and timers incorporated in the QE128. This figure illustrates the power savings attainable by gating off each module. Clock management enables to run fast when the CPU performance is the critical path. It can also allow to run slow when you are waiting on peripherals. The bus divider can be used to quickly reduce the frequency and instead of continuously reading a flag. Clever clock management means designers can use wait modes and interrupts instead. Using the external clock option uses the lowest power because the FLL is turned off. The QE128 can operate with both the internal and external oscillators enabled simultaneously. The MCU's power can be reduced by running some modules slower than others because modules can choose source. The external oscillator can be manipulated through settings internal to the microcontroller to set it to either high power or low gain. Low power settings limit the voltage swing on the oscillator pins to minimize power consumption. High gain drives oscillator pins to rail for robust operation in noisy environments. Voltage regulator is always on when the MCU is in run or wait modes. It is also on when in stop 3 with LVI or BDM enable. The regulator runs the internal logic at a lower voltage. Therefore, the MCU consumes less power. The new low power run and low power wait modes allow the peripherals to run while the voltage regulator is in standby. The regulator also has a faster startup, which allows more applications to use the stop modes. The QE128 has flash memory which is reprogrammable down to 1.8 volts. In applications such as remote controls, running off two 1.5 volt AA LR6 batteries means useful battery life is prolonged. The diagram highlights the advantage this feature gives to facilitate extended battery life. Should an application require that you write to flash to store data, for example, using the flash array to emulate EEPROM, the QE128 will allow the battery life to be extended. Here is a block diagram of a simple smoke detector. The MCU has one main input from the smoke chamber and two outputs, an alarm and an LED. The RTC module can wake up the device periodically from stop 2 so that the MCU can take a reading from the op-amp, process the data, and make a decision to go back into stop 2 or turn the LED on permanently, battery warning, and or raise the alarm. The MCU can then re-enter stop 2 to conserve power. The HCS08 has a slightly lower run mode current than the Coldfire V1 equivalent Flexis part, but the SC08 CPU has fewer data processing capabilities built in.